pleasant day to each and everyone. And the topic that we are going to talk about right now is about histogram. So at this time, allow me to share to you the first part of this presentation, in which I'm going to give you some concept of histogram and its parts. So what is histogram? Histogram, it was first discovered by Carl Person. The word histogram, it comes from the Greek word histos, meaning pole or mast, and gram, which means chart or graph. So when we talk about histogram, other people directly define it as a pole chart. So why histogram? It is simply because histogram looks like several poles standing side by side. The parts of histogram. So we have here the title, the x-axis, the y-axis, and the bars. So the title, it describes the information included in the histogram. So if we're going to refer these things into this example in your left side, the title here is the histogram for passengers. And then we have the x-axis. The x-axis are intervals that shows the scale of values which the measurement fall under. So the x-axis here is the passengers. And now we have the y-axis. So the y-axis shows the number of times that the values occurred within the intervals set by the x-axis. So in your left side, that is given the example of graph, the y-axis there is the frequency. And lastly, we have the bars. So the height of the bars shows the number of times that the values occurred within the intervals. So these are example of the height of the bars, this one. And the width of the bars shows the intervals that is covered. So this one. And for a histogram with equal beams, like for example to this one, this should be the same across all the bars. So that's the end.
Good day everyone, I am Angel Teres Cañete, and this time we will talk about the importance of histogram. Creating a histogram provides a visual representation of data distribution. Histograms can display a large amount of data and the frequency of the data values. The median and distribution of the data can be determined by a histogram. In addition, it can show any outliers or gaps in the data. The picture a histogram provides about the distribution of your process outcomes can help you determine what or where the problem might be. Dispersion of the data can produce a wide variety of histogram shapes, and each telling its own story. How to make histogram? As you can see in the right side, there is an example. First, on the vertical axis, place frequencies. Label this axis frequency. Second, on the horizontal axis, place the lower value of each interval. Label this axis with the type of data you used. Last, draw a bar extending from the lower value of each interval to the lower value of the next interval. The height of each bar should be equal to the frequency of its corresponding interval. That would be all. Thank you.
Types of distribution. 5 types are classified as 2. Let's go first with a symmetric normal distribution. It is also known as the Gaussian distribution. What does symmetric means? It's one in which the two halves of the histogram appear as mirror images of one another. Must follow a bell-shaped symmetrical curve centered around the mean. Second type of distribution is bimodal distribution. Can be symmetric or asymmetric, which means not all bimodal are symmetric and not all symmetric are bimodal. Right skewed distribution is also known as a positively skewed distribution. It is a distribution in which the tail is on the right side. The next type is the left skewed distribution, and also known as the negatively skewed distribution, one in which the tail is on the left side. And lastly is the random distribution. This type of distribution lacks an apparent pattern and has several peaks, it can be the case that different data properties were combined.
Hi, and welcome to this part of the discussion wherein I'm going to give you 6 common shapes of a histogram. So first up, we have the bell-shaped histogram, which usually represents normal distribution of data. So it has one peak and looks a lot like this. Next is we have the bimodal. So the bimodal histogram are like double bell-shaped histograms, thus having 2 peaks and looks a lot like this. Third, we have the skewed histograms, right and left. So the skewed right histogram has a descending order or sequence that will start from the peak and then will descend. Inversely, though, we have the skewed left histogram that has a ascending order or sequence, which will start from the bottom, then will ascend to its peak. So moving on, we have the multi-modal histogram that have several peaks close together. Thus the top of the distribution will form a plateau. That's why it's called the multi-modal or the plateau histogram. Next, lastly, we have the uniform histogram. So the uniform histogram occurs when there is a consistent, if the data is consistent. So thus providing peaks that are closely similar to each other in terms of value. That's all, and I hope you enjoy. Thank you.
So hello, good afternoon. To continue, the example of an histogram goes like this. So Zaminyaz is a nurse in duty at Mon Medical Hospital. Recently, she was being asked to write down the pulse rate or the beats per minute of 20 patients. So here are her findings from observing and writing down the pulse rate of 20 students. So in here, you will be able to see the minimum pulse rate, which is 53, and the maximum pulse rate, which is 92. So the next slide will be the frequency table, and here you will be able to identify the pulse rate and the frequency, and also the class width, which is 10. So the next slide, this is the corresponding histogram with 10 minimum bins. Yes, and it looks like this. So as we can see that there are three patients whose pulse rate is between 50 to 59, and 5 patients between 60 to 69, 6 patients is between 70 to 79, and 4 patients between 80 to 89, and 2 patients is between 90 to 99. So as you can see, you in here in the histogram chart, you will be able to analyze and know how did we come up with this solution, or how did we come up with this.
I am here to discuss about the disadvantages of a histogram. So histogram can only be applied in continuous data because histograms are used to kind of summarize all the means of a given set. So next is, it is more difficult to compare two data sets. As you can see in this example, it is very chaotic. It is completely random. So you cannot just easily compare both data and combine it for analysis. Next is, it cannot read the exact value of group data because they are grouped. As you can see, there is only a mean height, and you cannot pinpoint specific quantities in this given set of data. So that's all the disadvantages of histogram.